Good morning, students. Today we will do exercise 6.4, question number 4 onwards. Find the least number which must be subtracted from each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtain. That means given number is not a perfect square. We have to subtract a number from this number so that only we will get a perfect square. Square root of that obtained perfect square also has to be find out. How we will do? We will try to find the square root of this number. You will get a remainder. That remainder, when we subtract from the given number, you will get a perfect square. Let us try to do 402. We will make them into groups of pairs from right to left. So 0, 2 in one group, 4 in another group. Okay. So 2 2s are 4. We know that when we subtract, we will get the remainder 0, 2 only. Okay. Now 2 into 2, first number in the quotient, the first digit in the quotient, that double 4, we will write here. Okay. Second divisors, one of the part we will write 4. Now right side we have to put a digit so that here a proper number which is less than 2 we have to get. Okay, less than 2 or equal to 2. Equal to 2 you will not get because it is not a perfect square. Okay. So 41 into 1 is 41. We cannot write 41 which is greater than 2. So 40 into 0 is 0. Okay. So that 0 we are writing in the quotient also. So remainder is 2. We got the remainder 2. Therefore, the number to be subtracted is what? 2 only. And what will be the perfect square? 402 minus 2. That means 400. How you decide? We got a remainder. That means it is not a perfect square. When we subtract this remainder, we will get what? To obtain the required perfect square. So remainder we have to subtract and required perfect square is 400. Square root of that number is 20. Now 825. Same way we are doing from right to left pairs, arranging in groups of pairs. So 2, 5, 25 together and 8 alone. Okay, 2 2s are 4. 3 3 we cannot write because 3 3s are 9. 2 2s are 4. When we subtract what we will get? 425. Now 2 into 2 is what? 4. Okay. Now right side of 4 one digit we can write. So same digit we will multiply this number formed. So I have written 8. 48 into 8 is what? 384. That I have 8 ma'am has written in the quotient also. So 5 minus 4 is 1. 12 minus 8 is 4. This is 3 minus 3 is 0. So 41 is the remainder. This remainder, that means 825 is not a perfect square. You have to subtract 41 from this number. Okay. So when we subtract 41 from this number, what number you are getting? 784. It is a perfect square. So square root of 784 is 28. So which number to be subtracted? 41. And the obtained square root is 784. Obtained square number is 780. Sorry. Obtained square number is 784. And square root of that number is 28. Number 4, 4000. Here also same method we are trying to do the square root. Okay, take the square root. 0 0 1 pair and 4 0 together 1 pair. 6 6 are 36. 7 7s are 49 which is greater. So 6 6 are 36. 40 minus 36 is 4. 2 zeros more we will write here. Now 2 into 6 is 12. Here you got 12. And right side one digit you can write so that a number will be formed which will be little less than 400. Okay. 123 into 3 is 369. When we subtract 369 from that 3, we are writing in the quotient also. So when we subtract 369 from 400, you are getting 31. So the remainder is 31. That means when we subtract 31 from 4000, you will get a square number. So the number to be subtracted is the remainder 31. And what is the required square number? Subtract and see. 4000 minus 31 which is 3969. That is the square number. And square root of that number is what? Square root of 3969 is 63 only. Okay. Now second and third do as homework. Question number 5. Find the least number which must be added to each of the following numbers so as to get a perfect square. Also find the square root of the perfect square so obtain. Previous question it was which number to be subtracted. Now which number to be added. Okay. Here also we are trying to take the square root of the number. 525. 5 first 5. Okay. 2 2s are 4. Remainder 1. 1 then 25 fully we will write. Double of 2 is what? 4. 4's right side we can write one digit. It should be less than 125. Okay. little less than 125. 42 into 2 is what? 84. If you write 3, it will be greater. So, to that 2 we are writing in the quotient also. When we subtract, we are getting 41. Here remainder is 14, which shows that 22 square is less than 525. We have to add a number to get a perfect square. Next perfect square will be what? 23 square. Okay. Because here we obtained 22 square. We have to add a number with this. So we need a next perfect square, 23 square. 23 square is 529. Now we have to find out which number to be added. So that you take the difference of 23 square and 22 square. Difference of them is 4. That means if we add 4, we will get a square number, and square root of that number is 23. Okay. Now, second question, 1750. We are finding the square root of this number. Okay. What is that? When we 4 fours are 16. Now 1 is the remainder, 150. 4 twos are 8. One digit we have to write the right side of 8, so that we will get a number little less than 150. So 81 into 1 is 81. That one we are writing here. When we subtract, you are getting 69. That which shows remainder is there. Okay, so 41 square is less than 1750. Next perfect square is what? 42 square, which is 1764. Now we have to find out which number to be added to 1750 to get a perfect square. These two's difference, that means 42 square and 41 square, their difference will be the number to be added. What is the difference? 14. So when we add 14, we will get a perfect square. Okay. And square root of this number is what? 42. Same way 6412. We have to find out which number to be added to this number to get a perfect square. We are taking the square root. Okay. 64 together and 12 together. 6 and 4 together. So number formed is 64. 8 8s are 64. Here 8 we wrote in the quotient. Okay. Now 1 to 12 only. Now what you can write? 8 2s are 16. I wrote here 16 here. Now right side one digit you can enter. It should be little less than 12. Okay. 161 into 1 is 161. We cannot write that. So we are putting 0. 160 into 0 is 0 only. So remainder is what? 12. That 0 we are writing in the quotient. So what we have seen? 80 square is less than 6412. So we need some number to be added with this number so as to get a perfect square. Okay. So next perfect square is 81 square, because present one is 80 square, which is less than this given number. So 81 square, that is 6561. Okay, when we multiply 81 two times, we will get this number. So what number to be added to 80 square to get a perfect square? We have to take these two numbers difference. Okay, that means the number to be added to 6412 to get a perfect square is 6561 minus 6412, which is 149. And square root of the new number is what? 81. Okay. Now question number 6. Find the length of the side of a square whose area is 441 meters square. In a square, length and breadth, that means all sides are equal. So area of the square is what? 441 meters square. Side into side is area, that is 441. So side of the square, how you get when you take the square root of this number? Let us take the square root. From right to left, two digits in pairs. Okay. Here 41 together and 4 alone. 2 2s are 4. And remainder is 41. 2's double is what? 4. 41 into 1 is 41. So that one we will write in the quotient. So the square root of this number is 21. That means side of length of the square is 41 meter only. Now question number 7. In a right angle triangle ABC, angle B is 90 degree. If AB is 6 cm, BC is 8 cm, find AC. We are making the rough sketch of a right angle triangle. Given B is right angle 90 degree. So BC is given what? 8 cm. AB is what? 6 cm. And AC is the hypotenuse. We know hypotenuse square is what? Base square plus perpendicular square. Pythagoras theorem. So hypotenuse is AC. So AC square is, base square is what? 8 cm. 8 cm. Okay, that means 8 square. And perpendicular square is 6 square. Okay, so AC square is 8 square means 64. 6 square means 36. Their sum. 64 plus 36. AC square is 100. So AC is square root of 100. What is that? 10 cm. So length of AC is 10 cm. Same way, AC is equal to 13. That means hypotenuse is 13. BC is equal to 5. Base is 5. Find AB. AB is perpendicular. Also using Pythagoras theorem, P square, perpendicular square is hypotenuse square minus base square. That means our perpendicular square is AB square. AB square is 13 square minus 5 square. What is 13 square? 169. What is 5 square? 25. So their difference is what? 144. That means AB square is 144. So what is AB? Square root of this number. 144 square root is 12 cm. So length of AB is 12 cm. Now question number 8. A gardener has 1000 plants. He wants to plant these in such a way that the number of rows and number of columns remain same. Find the minimum number of plants he needs more for this. It is like that a number is given, what number to be added to get a square number. Such a way only we have to do this. That means 1000 is not required. We have to add 1000 some more number so that only we will get the proper arrangement as number of columns and number of rows same. Okay, total plants the gardener has is 1000. He needs some more plants that you know. First we are taking the square root of 1000. So how you take it 0 0 together 1 0 together. So first number is 10. 3 3s are 9. When we subtract 9 from 10 we are getting 1 and 2 zeros also we are writing. So the number is remainder is 100. Okay. Now 3 2s are 6 and you can write one digit right side of 6 61. Okay, we wrote 1. 61 into 1 is what? 61. 100 minus 61 is 39. Remainder is there. So what does it show? 31 square is less than 1000. Okay. So we are taking the next perfect square which is 32 square. So that is 1024. That means we need some more plants. How many more needed? Their difference you take. 1024 minus 1000. That means 24 plants. Okay. 1024 is a square number. So what does it show? 24 plants more needed for this arrangement. And how many total plants will be there? Find the minimum number of plants needed for this is 24. And how many total plants will be there? 1024 plants will be there. Question number 9. There are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to number of columns. How many children would be left out in this arrangement? Here what is given that there are total 500 children are there, but these all are not participating in PT. We have to reduce some number of children, but it should be in such a way the number of columns and number of rows are equal, so that you have to get a square number. Okay, and we have to reduce some more children. Question is that how many children will be left out? We cannot participate all the children because it should look nice, so that number of rows and columns should be same. Okay, so it is we are doing in such a way that which number to be subtracted to get a perfect square. Such a way here we are taking the square root of this number 0 0 together 5, 2 2s 5 alone. Okay, 2 2s are 4, remainder is 1 and 0 100. Double of 2 is what? 4. Now you can write one digit in the right side of 4 in such a way that we have to get a number which is less than 100 because it is not a square number. So 42 into 2 is what? 84. When we take the difference 100 and 84, you will get 16 as the remainder and 2 will come in the quotient also. That same 2. So what does it show? What does it show? Remainder is 16. That means we have to subtract 16 from 500 to get a square number. And required square number is what? 500 minus 16, 484. And square root of 484 is 22. You know 22 only. Okay. So 16 children will be left out for this arrangement. And number of columns and number of rows will be 22. Okay. We cannot include all 500 children. We have to reduce 16 more children. 16 children should be reduced. Okay. Then only. And how many children will participate? 484 children will participate and number of columns and number of rows will be 22.